In the last lesson, we learned about the crushing index reflecting the strength of coarse aggregate. We raised the question, if the crushing index is unqualified, can the aggregate not be used in engineering? Mr. Wei has encountered similar problems in engineering practice. In the number 1 overpass bridge project of Funying Road Connecting Line project in Nanying City, which Mr. Wei once worked for, C50 precast hollow beam slabs are designed to be made of Class 2 crushed stone. The laboratory test results show that the measured value of crushed stone is 22%, and the standard range is less than or equal to 20%. So, the crushing index used is unqualified. The supervisor didn't agree to use this crushed stone. The employer, supervisor, and construction contractor failed to find the qualified crushed stone at Wumying Quarry. The construction contractor was anxious because of the delay in the engineering. What should they do? After technicians studied and consulted standards, they found Article 3.2.5 in JGJ 52-2006, Technical Requirements and Test Method for Sand and Crushed Stone or Gravel for Ordinary Concrete. It says that the strength of crushed stone can be expressed by the compressive strength and crushing value of rocks, and the compressive strength of rocks should be 20% higher than that of concrete. In national standards, the strength of crushed stone is also expressed by the compressive strength and crushing value of rocks, and the compressive strength values of different rocks are also specified. Therefore, whether the crushed stone strength is qualified can be judged by measuring the compressive strength of country rock. So how to determine the compressive strength of rocks? The compressive strength is obtained when the rock is processed into specimens of regular size, measured, saturated with water, and compressed to failure under a testing machine. The compressive strength is equal to the load at failure divided by the cross-sectional area of the specimen.
This test is conducted according to the Standard for Technical Requirements and Test Method of Sand and Crushed Stone, or Gravel, for Ordinary Concrete JGJ 52-2006. Cut cubes with a side length of 50 mm, or drill test cylinders with a height diameter of 50 mm from rock samples. The top and bottom cross sections of the specimen shall be parallel and polished. There are 6 specimens in each group. 6 specimens shall be taken from rocks with obvious bedding along the directions parallel to and perpendicular to the bedding, respectively. The test cylinder is completely immersed in water and soaked for 48 hours. The surface of the specimen is wiped dry, and its size is measured with a vernier caliper, accurate to 0.1 mm. The dimensions are measured at the top and bottom surfaces respectively with the vernier caliper, and the cross-sectional area is calculated based on the average value of side length, or diameter. The specimen is placed in the center of the upper and lower pressure heads of the press machine, and the press machine loads at a speed of 0.5 to 1.0 megapascals per second until the test cylinder is damaged. R equals P divided by A. R, comprehensive strength of rock, megapascal. P, the load when the specimen fails, Newton. A, the cross-sectional area of the specimen, square millimeter. Take the ratio of the failure load of the specimen to the average cross-sectional area of the test cylinder as the compressive strength of the rock, and take the arithmetic mean value of the test results of 6 specimens as the compressive strength test result of the rock, accurate to 1 megapascal. When the difference between the compressive strength of 2 specimens and the average compressive strength of the other 4 specimens exceeds 3 times, The average compressive strength of 4 specimens with similar results shall be taken as the result. For rocks with significant bedding, the average value in both directions of perpendicular and parallel bedding shall be taken as the result.
The methods of rock compressive strength in different industry standards are the same, and the specimen is a cube or cylinder. There are slight differences, and the main difference lies in size. The two methods in GBT 14685-2011 and JGJ 52-2006 are suitable for construction and municipal industries, and the specimen size is a cube or cylinder with a side length of 50 millimeters. The Highway Industry Standards test methods of rocks for highway engineering, JTGE 41-2005, applies to highway and bridge engineering. The dimensions are different according to ground engineering, bridge engineering, and pavement engineering. When using it, you should pay attention to selecting the size of specimens according to different industries. Let's look at an example. The Overpass Bridge project of Funing Road connecting line in Nanying City. The measured compressive strength data of country rock are as follows. Please calculate the representative value of compressive strength. The first step is to calculate the cross-sectional area. Since the specimen is a cylinder and its cross-sectional area is circular, then the cross-sectional area equals pi r squared equals 3.1416 times 50 divided by 2 squared equals 1,963.5 millimeters. Similarly, the cross-sectional areas of the remaining 5 specimens are calculated and filled in the table. The second step is to calculate the compressive strength. Compressive strength equals failure load divided by cross-sectional area. Note that the failure load of 245 kilonewtons should be converted into 245 times 1,000 newtons and divided by the cross-sectional area of 1,963.5 millimeters squared equals 124.8 megapascals. Similarly, calculate the compressive strength of the remaining 5 specimens. The third step is to calculate the average value of the 6 compressive strengths. In the case of Funing Road Overpass Bridge, let's judge whether the strength of crushed stone meets the requirement. According to Article 3.2.5 of Technical Requirements and Test Method of Sand and Crushed Stone or Gravel for Ordinary Concrete, JGJ 52-2006, the compressive strength of rocks shall be 20% higher than that of concrete. The compressive strength of rocks is 126 megapascals, and the design strength of concrete is C50, which can be considered as 50 megapascals. After calculation, the compressive strength of rocks is 152% higher than that of concrete, far greater than the required 20%. Therefore, the compressive strength of crushed stone meets the requirements. It indicates that the strength of crushed stone meets the requirements. Finally, the supervisor signed and agreed to use the crushed stone in this project. A knotty problem was at last solved. Class, today we learned the determination method of coarse aggregate strength, compressive strength of rocks. In engineering practice, the strength of coarse aggregate is generally reflected by the crushing index. When in doubt, the compressive strength of country rock shall prevail. The test steps of compressive strength of rocks can be summarized as cutting or drilling, soaking, rubbing, measuring, and pressing. For the calculation of compressive strength of rocks, attention shall be paid to the unit value of cross-sectional area and load. The unit of cross-sectional area is millimeters squared, and the unit of load is Newton. Now, do you realize the importance of learning technical knowledge, studying specifications, and applying them flexibly? If you encounter similar problems in engineering practice, do you know how to analyze and solve them? That's all for today's class. Thank you.